Good morning, everyone, and welcome to today's lecture. In the last lecture, we were doing questions on the horizontal plane. We had seen some questions where bodies were moving on the x-axis, and we have solved a couple of problems on catching up. How can one catch up the other one, and all that. We will continue with the same thing, but now the scenario has changed and the motion is going to take place not on the horizontal road but in air under the influence of something known as gravity. Do you know what is gravity? What is gravity? No idea what is gravity? Gravity is the gravitational force of earth. So if something is falling freely under the force of earth, that is known as gravity. Every body which is near to earth, small body which are near to earth attracts them. The body also attracts earth, but earth also attracts the body with a force that is known as gravitational force of earth. That is known as gravity. Because of this force, F is equal to ma, this force produces an acceleration, and that acceleration is known as the acceleration produced by gravity is known as, you must be knowing it, right? Acceleration produced by gravity, it is known as, the acceleration that gravity produces is known as what? You must have heard about it. Tell me. What is that acceleration known as? Whether you know it or you don't know it. Either you know it, so tell me, sir, we don't know. If you know it, please try. Sitting quiet does not help much purpose. So what is the acceleration that is produced by gravity known as? Does anyone know it? I'm waiting. If you don't know, tell me that you don't know. Not a problem. But if you know, tell me. Yes? I'm waiting your answers. I hope you can hear me. You can see me, right? No one knows it? Say that you don't know. If you can't say, type it that you don't know. Not a problem. Say something. What is the acceleration produced by gravity known as? Discuss it among yourselves. Tell me.
We don't know, sir.
Okay, you don't know? It is known as acceleration due to gravity. It is written by small g. It is always taken as downwards. and the value is 9.8 meter per second square. Or you can also take it as 10 meter per second square. You have never heard about it? Well, today is the day that you heard about it. Every day you learn something new. Acceleration due to gravity, small g, 9.8 meter per second square or 10 meter per second square. It is always taken as constant. So that is what you need to remember. Oops. It is always taken as a constant. This is taken as a constant always. The value is 9.8 meter per second square and the direction is downwards. Will you remember it now? Having heard it at least now today on the 20th of October 2022 at 9:41 a.m. We've heard about acceleration due to gravity. Congratulations. Remember it, and it is always constant. Now, whenever we talk about motion under gravity, which we'll be doing in this chapter, also in the next one, we'll be solving it using some equations. So you can write the equations now. Equations of motion under gravity. Remember, this motion is constant with constant acceleration. So right now we are going to write the equation of motion for constant acceleration. The only thing is now it is under gravity. Can you tell me what would be the first equation of this motion under gravity? What would be the first equation? I'll tell you the first equation, then I'll hope that you can tell me the second one. V is equal to U plus AT. That would be the first equation that we are going to use. The only thing is here, one thing is always known to us. What is that thing that is always known to us? That is the value of A. Acceleration is always equal to G. And G is always downwards. Now also remember that whenever we use this equation, we use them with a proper sign, proper direction. Anything which is directed upwards will be taken as positive. Anything which is directed downwards will be taken as negative. So in that scenario, G will always be equal to minus 9.8 or minus 10 meter per second square, because no matter what happens, it is always directed downwards. Do we understand this? Please raise your hands and let me know that we understand this. Acceleration, please note it down and write it, that acceleration due to gravity is always constant. It is always downwards, so it always would be negative. Yes or no? Okay, that was the first equation. Can you tell me what would be the second equation? Second equation. Yes.
S is equals to ut plus half at square.
Okay, displacement, I don't call it S, I call it delta R. Doesn't matter. Here I can call it as H as well, because the particle is going to move up and down. You can talk in terms of height. So H is equal to ut plus half at square. Here also one thing is always known. What is that? That is A. This A is always equal to G, and this G is always negative 9.8 or negative 10. Do we understand this? That takes us to the third equation. What will be the third equation that we must understand? The third equation is this: V square is equal to U square plus 2G. Oops, let us not write G. 2AH. What? One thing you should always remember, this A is always equal to G. Do we understand this? You can also write the fourth equation. Oops. You can also write the fourth equation. And how do we write the fourth equation? Displacement in the nth second or height covered in the nth second will be equal to u plus a by 2 into 2n minus 1. Remember that this a is always equal to g. Do you understand this? If you don't want to remember the equations in this way, you can straight away put the value of a as g and write the equations again if that suits you. So in that case, your first equation will look like this: v is equal to u minus gt. Here I have put the value of a as minus g. Do you understand this? So you can write the first equation like this. Then how does the second equation look like? If I just put the value of a as minus g, how does the second equation look like? I can write h is equal to u t minus half g t squared. I've just put a as minus g because a is always negative g. How does the third equation look like? V squared is equal to u squared minus 2gh. Remember, I have put the value of a as minus g, but the rest of the things you will have to put with proper signs. What will be the fourth equation looking like? Height in the nth second will be equal to u minus g by 2 into 2n minus 1. If the right hand side wala equation looks better for you, you can use those. The left hand side equation looks better to you, you can use those. It's up to you. How do you want to use them? Do we get this? Yes or no? Remember, I put the value of a as minus g, but the rest I have not changed. So you'll have to see how is the different values of v, u, and h are. Anyone understands this? Everybody noted this down? Please let me know. I'll give you 2 minutes to note it down, and then I'll come back and we'll solve some cases. Once you are done, please tell me that you are done. One class I just can't see, so please tell me from that class if you are done or not. Have you noted it down, everyone? Okay. That takes us to the first case, and in that first case, what is going to happen is that a body is going to be dropped from some height. So you will have someone standing on the top of a tower, top of a building, top of a mountain, and dropping something. Now this dropping, whenever we use this word dropping, this dropping tells us something about the initial velocity. Whenever someone uses the term dropping, it tells us something about the initial velocity. In this case, when I'm dropping something from the height of the tower, from the top of the tower, I'm dropping it. The word is dropping, dropping. If I'm dropping something from the top of a tower, it tells me about its initial velocity. What can you tell me about the initial velocity of this object? What is the initial velocity of this object that I have dropped? This is a ball that has been dropped. What is the initial velocity of this object? The initial velocity of this object is 0. Do we understand this? Initial velocity of this object is 0. So that is the first thing that is known to us. That is the first thing that is known to us. The second thing that is known to us is the height of this tower. Do we see this? Normally, this height of the tower is known to us. Two things. We also know one thing, that the acceleration of this body is constant, and this is how much? it is minus g. Do we understand this? These are the three things that are normally known to us. This a is equal to minus g is always known to us. In this case, this u, initial velocity is 0. This is known to us. And the third thing that might be known to us will be h, the height from which it is dropped. What is not known to us? Can you tell me what are the things they can ask us in question? What are the things that are not known to us in this particular question? There are two things that can probably be unknown to us. The first thing is time. How much time it takes to fall. That is one unknown. And the second thing that is unknown is v, the velocity with which it touches ground. You will say, sir, we know this. The velocity with which it touches ground is 0. It does not go anywhere. No, beta, that is not 0. Because when I am saying that the velocity with which it touches ground, it is the velocity with which it just reaches ground. After impact with the ground, what happens, that is not considered. So when I say the velocity with which it touches ground, it is the velocity just before touching. Do we understand this? So there are two things that are unknown in green. One is the time of flight or time of falling. The other is the final velocity v. Do we understand this? And we'll have to find out the value of t and v. How are we going to do that? We only have three equations to deal with. What is the first equation? What is the first equation?
V equals to U minus GT.
V is equal to u minus gt. Very good. From here, you can see that u is 0. So u goes away. We get a simple equation v is equal to minus gt. What does this negative sign indicate, beta, in this equation? This negative sign only indicates that the velocity, final velocity, is downwards. Do we understand this? So from there, you can get the formula of t. T is v by g. Here I have neglected the negative sign. V is also negative. G is also negative. Both are negative. Both negatives will cancel. And therefore, I can write the time as v by g. Do we understand this? That is the first formula that I have created, which relates v with g. V is minus gt. Minus sign indicating that it is downwards. Time is v by g. Why I'm not calling it v by minus g? Because v is also negative, g is also negative. They will get cancelled. Finally, we'll get time as positive. Do we understand this? If I put the second equation is h is equal to ut minus half gt square. Yes or no? Here again, u is 0. This goes away. Now look at this h. The body is going downwards, therefore h is negative. Yes or no? So I will write it as, with proper sign convention, I will write it as minus h is equal to minus half g t square. This negative negative gets cancelled and I get the equation h is equal to half g t square. Do we understand this? H is equal to half g t square. Do we understand this equation? The pink one, this pink one, and this pink one. And from here, I can get t as 2 times h by g. Yes or no? That is the green equation that you see here. Time is 2h by g. So these equations have been derived from equation number 1 or from equation number 2. Let us see what we can get from equation number 3. V square is equal to U square plus, or should I say minus 2G. But remember, the height is also negative. Yes or no? Because it is coming down. Do we understand this? The height is also negative. It is coming down. U square is cancelled. Minus minus cancelled. So I get this equation. V square is equal to 2GH. Do we understand this? V square is equal to 2GH. This is the equation in yellow. If I take the root of this, I will get this equation in yellow. Do we understand this? Everyone is noting it down at the same time. Now, from this equation, I can also write H is equal to V square by 2G. This is the blue equation. So basically what I see is all these equations that are here on the left hand side are derived from equation number 1, 2 or 3. Do we understand this? Motion under gravity, something falling or drop from a certain height. These are the equations. I'll give you 1 minute to note them down. Once you are ready, please let me know so that we can solve some questions based on this. Shall we proceed with some question and answers? Okay. So here is the first question, and I hope that you can give me an answer quickly. A stone is dropped from a tower of height 20 meters. Find the time taken t to reach ground and the final velocity v with which it strikes ground. G, if you require, take it as 10 meter per second square. So this is a straightforward question. A stone is dropped from a tower of height 20 meters. After how much time it falls and with what velocity it falls on the ground? Two questions, simple ones. Please tell me the answer. Yes, Bacha, do we have an answer?
T equals to 2 seconds, sir. V equals to 20 meter per second.
Well done. That is great. That is the answer. So how do we do it? Can straight away apply the formula for time. Time is under root of 2h by g. Yes or no?
Yes, sir.
Just put the values, get the answer. 2 into height is 20 divided by g. Remember, I have not put the sign here because I have already put the sign in the original equation. Yes or no? So don't have to put the sign. G, sorry, I've written G. G is 10. I should have written 10. The answer is 2 seconds. Do we get this? Yes or no? No, yes. What about the value of V? I can write the value of V simply as root over 2GH. Yes or no? No or yes? So it is 2 into 10 into 20. If you take the root, it will be root of 400. Root of 400 is 20 meter per second. These are the answers that we are looking at. Everyone got this? Yes or no? Remember the simple things and you will be rewarded. This is the next question. It has come multiple time in multiple exams. This is your turn to do it on your part. A stone is dropped from the top of a tower. It touches the ground in 4 seconds. What is the height of the tower? I'll give you 2 minutes to solve it. Yes. Do we have anything that looks like an answer? Yes, bacha.
Option C, sir, 20 meters.
Option. Okay, I did not see the option C, 20 meters. How did you get it? A body is dropped from the top of a tower. So that tells me that the initial velocity is 0. It touches the ground in 4 seconds. That means time is given as 4. You have to find out the height of the tower. Which formula you should have applied here, my dear friends? Which formula you should have applied here? The formula is right here in front of you. Which formula you should have applied here? This one. Can you apply it now and tell me what is the answer? Yes, my dear friends, the formula straight away is h is equal to half gt square, negative sign getting cancelled from both sides. So h is equal to half g is 10, t square, 4 square is 16. What is the answer that you are getting, my dear friends?
80, sir.
80, sir. That is correct, sir. 80 meters. That should be the correct answer. I hope you have understood what.
A,
Yes,
sir.
got it?
A.
Sir. That is correct, sir. 80 meters, sir. That is correct, sir. Do we understand how this question is to be done? Yes or no? No, yes. Arey, we understood this?
Sir, understood.
Everyone?
Yes, sir.
Okay. Here comes the next one. Are we ready for the next one? This is the next question. I'll call it question number 4, I think. 3 or 4, I've forgotten the count. A body falls from rest in the gravitational field of Earth. What does that mean? This is motion under gravity. Yes or no? It is dropped. So initial velocity is 0. The distance traveled in the 5th second of the motion is. The distance traveled in the 5th second of the motion is. I give you 2 minutes to solve this.
Forty-five, sir. Option B.
Option B, 45. How did you get 45?
Fourth formula I used, sir.
Four formula, yes.
U
I
minus G by 2, 2n minus 1.
U minus G by 2. I've already put G as negative. 2n minus 1. That is correct. So U is 0. Don't have to do it. Height in the nth second is minus because it is downwards. G is 10. 10 by 2. 2 into 5 minus 1. 2 into 5 is 10. 10 minus 1 is 9. 5, 10 by 2 is 5. 5 into 9 is minus 45. What does this minus sign indicate? That this is going downwards. Do we understand this? Yes or no? No, yes.
Yes, sir.
Everyone understands this? The class that I can't see. Do we understand this? I hope, even if I can't see it, we are there in the same universe. This universe is good. S is equal to ut plus half at square. Shall we move on to the next question? The more the number of questions you do, the better you are going to be. I have forgotten the number. I will call this as question number 5. Shall we move, beta?
Yes, sir.
Question number 5, sir. A body is
Okay,
released.
sir.
A body is released from the top of a tower of height h. It takes t seconds to reach ground. Where will the ball be after t by 2 seconds? Shall I solve it for you? Or you want more time? Okay, so this is how you solve it. You draw a diagram. The height of the building is given as h, and it is given that it takes t seconds to fall. Yes or no? T is the time it takes to fall. Now you can make one equation which relates h and t. Remember, it is release or drop. So the velocity at this point is how much? Initial velocity is 0. Yes or no? You can make an equation which relates h with t. What is the equation that relates h with t? H is equal to half g t square. Yes or no? H and t are related. So it will fall a height h in t seconds. We have to find out where it is after t by 2 seconds. So let me call that point as C. It takes time t by 2 to fall from A to C. Let me call this height as y. Let me call this height as y. I can relate this y with t by 2. If I make the equation from A to C, what is the displacement? It will be minus y in the downward direction. That should be equal to u into t. U is 0. Minus half gt square minus half g. How much is the time? T by 2. T by 2 square, it becomes t square by 4. Yes or no? Minus minus cancels. Y becomes 1 by 4 times half g t square. Yes or no? But this half gt square, my dear friends, is nothing but equal to h. So my y becomes h by 4. Do we understand this? So my y becomes h by 4, and the correct answer is option B. Yes or no? H by 4. Do we understand this? Yes or no? No, that is wrong. This y is from the top of the tower. This y is from top of the tower. So what is the distance from the bottom of the tower? This distance. What is the distance from the bottom of the tower? What is the distance from the bottom of the tower? What is the distance from the bottom of the tower? Or from the ground? H by 4 is the distance from the top of the tower. What is the distance from ground? Difficult to understand? Can you tell me the answer, bacha? Total height is h. From the top, it is h by 4. So what is the height from the bottom? Yes. This height I am talking about, my dear friends. How much is this height? Total height is h. It's such a complicated question. Total height is h. From here to here, height is h by 4. So what is the height from here to here? Can anyone tell me? I'm waiting for your answer, beta.
Sir,
Option?
D.
Option D. Well done. I got a voice. Option D. This height is 3h by 4. That is the correct option. I'll give you 2 minutes to note it down. If you have any doubts, please ask. Once you are done, please let me know.
Completed, sir.
Well done. Do you understand the question, bacha, how it is done?
Sir.
Okay, good.
Next question.
So now we move on to the next case. And in next case, the body is going to be thrown upwards from ground. In the first case, it was dropped from the top of a tower. Now it is thrown upwards from ground. So how does it look like? Let me just show you how does it look like. And again, we will have some things that are known to us, some things that will be unknown to us. We'll have to find the unknowns in terms of things that are known. So what are the things that are known to us? If I throw a body vertically upwards, I will know that the initial velocity is given. Yes or no? So u will be given to me. Since the body is thrown up, this u will be positive. Yes or no? U will be given and u will be positive. That is the first thing that is known to us. What about acceleration? How much is the acceleration? No matter what happens, acceleration is always equal to minus g. So this is the second thing that is known to us. First thing that is known to us is u. Second thing that is known to us is acceleration is equal to minus g. Third thing we can understand from our understanding of common sense, when it reaches its highest point, when it reaches the highest point, let me call the highest point as A and let me call the lowest point as B. When it reaches its highest point, what would be its velocity at the highest point? When it reaches the highest point, what would be the velocity at the highest point? Any idea? What would be the velocity at the highest point? When it reaches the highest point, what will be the velocity? The velocity at the highest point is going to be 0, because if it is not 0, it will keep on going up. So these are the things that are known to us. The initial velocity is known. The final velocity at the highest point is known. Acceleration is known. Do we understand this? Then we don't know what is time. So you can calculate time using this equation. This is the time taken to go up. This is the time taken to go up. You can write the formula for this. How are these formulas attained? V is equal to U plus GT. You will apply, U minus GT, I must write. You apply this formula. V is 0, U is given. You will get the formula of time as U by G. Do we understand this? That is how you will get the formula. You can apply the second formula. H is equal to UT plus half GT square. That is the second formula. Sorry, it's not plus half GT square. It is minus half GT square. Okay. The third formula that we have is V square is equal to U square minus 2GH. When you apply these three formulas, as in the previous case, you will get simple results. For example, the first result is time taken to go up would be equal to root over 2H by G. That will be equal to U by G. Whatever time it takes to go up, same time it will take to come down. So the total time, how much will be the total time? Time total will be 2 times U by G. U by G it will take to go up. U by G it will take to come down. Total time would be 2U by G. Do we understand this? The second formula that you can get is same as what we got in that case. Here you will get U is equal to root over 2GH. You can write this formula in different form. H is equal to U square by 2G. In fact, this case is the exact opposite of the first case. In first case, initial velocity was 0 and final velocity was V. Here, initial velocity is U and the final velocity is 0. Do we understand this? So this case is exactly opposite to the first case that we did. Do we understand this? Yes or no? I'll give you 2 minutes to note it down and then I'll give you a question to wind up this class. Have you noted it down, bacha? Okay. Are we ready for the question? Here comes the question. A body is thrown up with a velocity of 15 meter per second. What is the maximum height attained by it? G has to be taken as 10 meter per second square and I'll give you 2 minutes to solve this. Did you get the answer, my dear friends?
Yes, sir.
Option?
A.
Well done. Well done. It is very simple. H is u square by 2g. The more you use this formula, whether the ball is thrown up or whether the ball is dropped down, the better you are going to become. So you just put the values, get the answer, and stay happy. 15 square divided by 2 into 10. And comes your answer, my dear friend. 225 divided by 20, 11.25. Everyone got this answer? Yes or no? No, yes. That brings us to the end of this session. The next session we'll do two more problems on this. Then we will move on to the last section of this chapter, which is graphs, maths and graphs. So will we deal with this? I hope everyone has noted down this question. Yes or no? If you have any doubts, you can always reach out to me, put your doubts on the Telegram group, and I will be the first one to solve them. See you in the next class. Take care. May God bless all of you. Bye bye, bache.